Welcome back to Through Inquisitive Kids. In this video, we will be talking about variables and equations. This is our second video and second lesson of this chapter, and in our previous lesson, we talked about variables and tables. Learning goals for today: be able to use functions to express the relationship between independent and dependent variables, and we're going to improve our ability to analyze and solve word problems. Here's some review. In the toy car experiment from our last lesson, the height of the ramp and the sliding time of the car were both changing, so they were both variables. T changes as H changes, so T is kind of relying on H, which means that T is the dependent variable, it depends on H, and H is the independent variable. Introduction. Counting frogs. 1 frog, 1 mouth, 2 eyes, 4 legs. That makes sense. 2 frogs, 2 mouths, 4 eyes, and 8 legs. 3 frogs, 3 mouths, 6 eyes, 12 legs, and so on. What is the relationship between the number of eyes and the number of frogs written in mathematics? So how can you express that in an equation? And what is the relationship between the number of legs and the number of frogs in mathematics? So for the first question, we can see that when there's 1 frog, there are 2 eyes. I'll write E for eyes. So E, the number of eyes, would be equal to 2F. The relationship between the number of legs and the number of frogs would be L, the number of legs, equals 4F. How many total bodies there are. What are the quantities that determine the area of a triangle? Here we have a triangle. And we know that a triangle has a base and a height. The formula to calculating the area of a triangle would be 1/2 base times height. 1/2 is our constant. B is our base, that's a variable, and H is also a variable. As shown in the figure, the height of the base of the triangle ABC is 6 centimeters. As the vertex C of the triangle moves along the base towards point B, how does the area of the triangle change? So if we start off as this big triangle ABC, and then C starts moving closer and closer to B. As you can see, the area of the triangle gets smaller and smaller. The length of the base is the independent variable because that's what we are constantly moving around, and the area of the triangle is the dependent variable. It gets changed because the base gets changed. If the length of the base is X centimeters, then the area, Y, would be expressed as Y equals to 3X. When the length of the base changes from 12 centimeters to 3 centimeters, the area changes from 36 centimeters to 9 centimeters. So Y equals 3X represents the relationship between the area of the triangle and the length of its base, which is the relationship between variable Y and variable X. Here we have independent variable X. We put it through the function Y equals 3X, and out comes the dependent variable, or the result, variable Y. So functions are a mathematical way for us to express the relationship between variables. From the function Y equals 3X, we can calculate the value of the dependent variable that corresponds to each independent variable. What is the formula to find the volume of a cone? What quantities do each variable represent? Here we have the formula we use in order to find the volume of a cone. V is the volume, that's the dependent variable. So I'll write dV for short. 1/3 pi is actually a constant. Pi is a constant value. R would be an independent variable, and H would also be an independent variable. As shown in the figure, the height of the cone is 4 centimeters. As the radius of the base increases, the volume of the cone also changes. In this relationship, what are the independent variables and what are the dependent variables? So the radius of the base is independent, while the volume of the entire cone would be the dependent variable. If the radius of the base is r centimeters, that's its variable, then the volume of the cone would be expressed as V equals 4/3 pi r squared. That's the formula to finding the volume of a cone. When the radius of the bases change from 1 centimeters to 10 centimeters, the volume of the cone changes from 4/3 pi to 400 over 3 pi centimeters cubed. Here's some practice. A small ball starts to roll down a slope from the top, and the distance s meters and the time t seconds of the rolling time can be found in the following table. So I want you to write out the relationship between t and s. S equals 2t squared. That is the pattern you will find after looking at this table. What you can first do is observe the corresponding values of t and s, and then analyze the changes in value. Then you can write our function. Example 2. The dots are arranged in a pattern as shown in the figure. Let y be the number of dots on the nth layer. N is a natural number. Which of the following functions represent the pattern? So pause the video and observe the pattern yourself first. From the figure, when n equals 1, there are 4 dots. When n equals 2, there are 8 dots. When n equals 3, there are 12 dots. So if you write out a table of your own, you will find that the equation would be y equals 4n. So in the previous lesson, we learned about how to observe tables. In this lesson, we are technically going one step further from looking at tables. We are starting to write the table into a mathematical equation. So our answer would be B. Class summary. Here are actually 2 ways to find the relationship between variables. So based off of the data in the table, you can summarize the relationship between 2 variables. And then you can use functions to express the relationship between 2 variables. That's how you write a sentence in the mathematical language. Area and volume formulas of geometric figures are good examples. As you can see, we looked at the formula to finding the volume of a cone, and we tried to identify the independent and dependent variables in that formula. I hope you learned something in this video, and I hope you'll come back for the next lesson.